Hello Math 20-2 and welcome back. Today we are doing lesson 2 of trigonometry. So we're looking at sine law today. Most of our triangles that we've looked at so far were right angle triangles or shapes consisting of right angle triangles that we can solve using trigonometry. Today we're going to eventually discover how to solve certain types of triangles that aren't right angle triangles if we know certain things. So we look at our first triangle here. It is not a right angle triangle. But conveniently for us, we are given this right here and separate into two perfectly right angle triangles. This won't happen all the time, but here's a first example, and we're going to break into it using this triangle. So we want to find the length BC, all right? Now, if I look at just BD, that is part of the length BC. Now, BD here is opposite of 20 degrees. We know angle 20, and BD is opposite of 20 degrees. We also know the hypotenuse of this triangle is 12.5. So if we're looking at opposite and hypotenuse, we're using our sine law. So I'm going to go sine 20 is equal to, well, we're looking at length BD, it's opposite over hypotenuse, so that over 12.5. Okay, so we continue this off, now we're going to have to solve it. So I have is equal to line BD. Okay, now I'm going to turn on my calculator and figure out how to do this. So I'm just going to type in 12.5 sine 20. That's going to give me 4.3. Oh, it wants two decimal places, so 4.28. That's centimeters. Okay. So now, we also want to find here, it is important to find DC. But we don't know any of these distances in this triangle. We don't know any of the lines. So I'm going to use this here, again, our first triangle, to find this distance here, AD. So AD is crucial to know. We have to figure out what is the distance AD. So if we're looking at this angle 20 again, we are going to have to look at cosine, okay? Or I could look at this sine, if I look at this here, B, I could use sine of that one, okay? We could use either method. So I'm first going to use cosine 20. Now, the adjacent is what we're trying to figure out, and we know the hypotenuse right here is 12.5. So we continue this, I'm going to get enter a calculator, and I'm going to get 11.75. And that's my value for line AD. So now we know this is 11.75. Okay, so now we have to figure out DC. Well, I look at DC, and it doesn't matter which angle you use. You can use 35 or 55, it's up to you. I'm going to use the 55. So, because it's easier. Actually, I'll use the 35 because it's a little bit more complicated of calculation. I'll just show you that calculation one more time and reinforce it. So if I'm going to use tan 35 is equal to opposite over adjacent. So the opposite here is this 11.75, and adjacent is DC. So, continue this. We want this DC, this is my variable, or I could say x, on top, because we don't like a variable on the bottom. So we have DC, tan 35, is equal to, okay? So we divide both sides by tan 45, so I get C is equal to 11.75 divided by tan 35. There we go. So I'm going to put it in my calculator and see what we get. So we have once again, when you're doing these calculations, it's very important that you make sure your calculator is in degrees and not radians. So I'm going to get 16.78. Well, we're not done yet. We have to add the BD and DC together. So that's going to give me, we add to this 4.28. It's going to give me 21.06. Okay? So that is how we solve these questions, or one way. It's kind of a long way. There's a lot of work here. There is a slightly better and more efficient way. And that's when we're going to get into this called the sine law. Okay? So here is your sine law. We could either do it two ways. We could look at it this way. The opposite side divided by its corresponding angle. So if we look at it, this would be A right there. This would be side B. This would be side C. So angle A, or A divided by angle A, sine A, angle A, is equal to B divided by sine B is equal to C divided by sine C. Or if we just flip those, it has to be the same ratio because these numbers should be the same ratio. It's just the reciprocal ratio. So there is your main sine law. It's up there. Now, right here, if you follow this through, and I'll give you guys a couple of minutes, I expect you to pause it and we'll do a couple of minutes, this will follow the proof of sine law A. So I really do expect you guys to go through that just a little bit there, just so you get more understanding of how it works and why. Yeah. Here we go. So we're going to try now class example 2 using the sine law. So it's the same one, it's angle BC using SOHCAHTOA. We did it in SOHCAHTOA, now we're just going to use sine law. So if I look at this, we know C, and this is side C. So I'm going to go and I want to find BC. So this is side A. So we know that A over sine A is equal to C over sine C. Now, which one do we not know here? Let's plug in everything we know. We know A is our unknown. Sine 75, because this is angle A, is equal to 12.5 sine 35. So now we have to isolate A, so I'm going to multiply both sides by sine 75. Okay, so we're left with A is equal to sine, or 12.5 multiplied by sine 75 divided by sine 35. Okay, so now we're just going to use a calculator and multiply that out. So I have, make sure you can see this all, 12.5 multiplied by sine 75. And I'm going to divide this all by sine, what was it? 35. That's going to give us 21.05. So that's pretty close. Last time I rounded off. This is exact 21.05. So if we look at this, this is a lot faster way than doing it the other way. It's helpful, it's faster, it's more efficient. It's just one simple calculation. Because even if we look at the last triangle here, if we add 20 to 55, that's 75. So it's the exact same triangle. It's just not separated. So let's take a look at question exit class example number 3. So use the sine law for this triangle now. So we have A, this must be A, 6, this is angle B, so this is B, and we want to figure out ACB. Okay, so then this here is angle C, and this is C. Alright, so if I'm looking at this here, in order to figure out this angle here, I have to figure out one more angle, because the sum of angles in the triangle is always equal to 180 degrees. But I only know one angle. So I'm going to have to figure out this angle here because I know side B and that. So that's my ratio I'm going to look at. So I know B is equal to 6. I know A is equal to 9.4. And I know angle A is equal to 110. So I need to know at least 3 variables in order for one of the ratios to work. So with these 3 variables, I can figure out this B. And from there, if I know this angle, I can figure out that. So let's try this out here. So I'm going to leave my angle on top because I don't like my variables on the bottom. We're going to try and figure out B. And so I'm going to put my angles on top. So I'm going to have sine B all over 6 is equal to, now I'm going to have my ratios of A. Sine A, sine 110 all over 9.4. So once again, we want to isolate for B. So I'm just going to go like this, multiply by 6, multiply by 6. So I'm going to end up getting sine B is equal to sine 110 multiplied by 6 divided by 9.4. So I'm just going to figure out what that is in my calculator right now. Oops. So we get 0.59 or 0.6 right there, okay? So I'm going to get 0.6. So I have sine B is equal to 0.6. Now, to solve this part, I just wrote B, remember from last class, is equal to, okay? So I'm just going to second sign my answer here. And I'm going to get 37 degrees. Okay? Now, with this information, I can actually find that angle C, because these add up to 180. So 37 is equal to C. So then C is equal to 33 degrees. There we go. Now let's take a look at question number 4. So a surveyor measures the baseline PQ to be 440 meters long. So we know PQ is 440. Okay. He takes the measurements of landmark from P so that's 440. So then he takes measurement from R, landmark R from P and Q. So then angle QPR is equal to 46. So QPR is equal to 46. And then he has angle PQR is equal to 75. So PQR is equal to 75. All right? So calculate the perimeter of this shape. So this right here is really angle P. So we know P is equal to 46. And take a look at this here. We know little p is equal to question mark. Okay? Now we have Q is equal to 75. Little q is equal to question mark. And R, well, if I know these two angles, can I figure out R? Yeah, obviously. So I'm just going to figure it out. It's 180 minus 75 minus 46. And we're going to get 59. Okay? So it's 59 degrees. So angle R is equal to 59 degrees. Now we're just going to have to find out. And we know R is equal to 440 degrees. Okay? So let's continue working at this now. Alright. So which ratios do we have 3 of? Well, this is my key one that we know. So we know we're trying to find our distances, so I'm going to put our distances up top. So I'm going to first find this side P here, this is R, and then I'll assign this Q there. Okay, so let's try this one right here. I'm going to get R is 440 all over sine 59 is equal to, well, let's take a look here. We have, we're doing P all over sine 46. Now we have to isolate for P, so we multiply everything by sine 46. And we end up getting P is equal to Now, one thing I don't want you guys to do is when you see this, don't cancel off the sign and just divide those. You actually have to type everything in. So I've seen those as some errors. So let's try this out here. I'm going to have sine 46 multiplied by 44, oops, and sine 46 multiplied by 440, and then I'm going to divide it by sine 59. So I'm going to get 369. So P is equal to 369 meters. Okay? Now let's try to find the other one right here. We're going to find Q. So Q is going to be Q, and I'm going to already go ahead and multiply everything over. So Q is equal to, we have R, which is 440, all over sine 59. Then we're going to multiply that by sine 75. Okay, I just kind of skipped a step there for you guys to follow in. Okay, now we multiply that out. So I have 440 multiplied by sine 75. And then I'm going to divide that by sine 59. So I get 495.8, which is 496. So we add all of these together, and I'm going to get 1,305 meters. Okay. So there we go. I hope you understood all this. I'll see you tomorrow in class as we try and do the assignment together. Have a good evening.